All right, so far we've studied square systems, and square systems are basically where the number of equations equals the number of variables. So we've had three equations and three unknowns, right? And it's possible to have a unique solution. Unique solution just means there's one solution. But if you have a non-square system where the number of equations does not equal the number of variables, you're guaranteed no unique solution, which often means that there could be infinite solutions. Okay, so typically this is the case where you have infinite solutions. You can also get infinite solutions if it is a square system, but you're guaranteed infinite solutions for a non-square system. All right, so again, there's three possibilities, right? You can have, one unique solution, which is what we've got in our first two examples. And then, of course, you could have no solutions, right? And then, of course, you can also have infinite solutions. Those are the three possibilities. And keep in mind, right, a system of three equations, three unknowns typically involve planes, especially if there's three variables. All right, so let's take a look at this one. So if I ask you, is this a square system or non-square system? You would say it's a square system because you have three unknowns and you still have three equations. So it's not a non-square system. But just because it's a square system doesn't guarantee that you have a unique solution, right? It says it's possible to have a unique solution. So this looks kind of weird, right? Because you're missing a y here. But that's okay, right? You could still put in row echelon form, even if it's missing something here. I'm just going to simply add row 1 and 2, row 1 and row 3 to start us off. And I'm going to replace row 3 with this result. Okay, so the first result we'll have is 2x plus y minus 3z is equal to 4. I'm going to stagger this, right? This is in the x column. 2z's and over here is equal to 10. And then let's do the arithmetic. 2x minus 2x is 0x. Y plus 3y is 4y. Negative 3z plus negative 13z is negative 16z. And 4 plus negative 8 is negative 4. Okay, so again, I'm going to try to work my way from the bottom up. Now, the next thing I want to do, right, is somehow get rid of this 4x right here. And the way to get rid of the 4x, right, is take negative 2 times row 1 and then add it to row 2. So let's write this out. Negative 2 times row 1 plus row 2. And I'm going to replace row number 2 with it. So let me write row 1 again. 2x plus y minus 3z is equal to 4. And let's do the computation here. Negative 2 times 2x is 4x. Negative 4x plus 4x is 0. Negative 2 times y is negative 2y. Negative 2y plus 0y is negative 2y. Negative 2 times negative 3z is 6z. 6z plus 2z is 8z. Negative 2 times 4 is negative 8. Negative 8 plus 10, of course, is just 2. Okay? So now, right, I'm kind of where I sort of had in my other two examples where I'm working my bottom from the bottom up. And hopefully you can see right now I need to get rid of this 4y to put it in row echelon form because the directions say still say use Gaussian elimination. So whenever it says use Gaussian elimination, you basically have to put in row echelon form. Okay, so hopefully you kind of know where to go from here, right? Positive 2 times row 2 and then add it to row 3. So positive 2 times row 2 and add it to row 3. And replace row 3 with that result. Okay, so I'm going to write out equation number 2 again. And, all right, so let's do the math here. 2 times negative 2, y is 4y. Negative 4y plus 4y is 0y. 2 times 8 is 16z. 16z minus 16z is 0. And then 2 times 2 is 4. 4 plus negative 4 is 0. Okay, so we're in row echelon form, right? Because this one's a little bit weird, right? The 0 or the y and the z canceled out basically. And so if you remember, right, when you solved linear systems of 2 equations or even 3 equations back in Math 3, when you have a true statement, which it is, right, this is true, this implies there's going to be infinite solutions. Okay, if you wrote infinite solutions, that is correct, right? But in the back of your book, it gets a little bit more specific. So notice in the directions, right, I kind of neglected this here in the beginning. It says write infinite solution cases in terms of z. So what I'm going to do right now is I'm going to let z, and the letter they picked in your textbook is equal to a. All right, so z is equal to a, and then we're just going to back solve assuming that z is equal to a. So negative 2y plus 8. Now, instead of calling it z, right, we're going to call it a now, is equal to 2. And now what we're going to try to do is get y by itself. So 8a minus 2 is equal to 2y. Y is equal to 4a minus 1, right? And to get to get x, right, we plug it back into the first equation, okay? So 2x plus y, which is 4a minus 1. All right, this is my y, and then minus 3z, 3a, and we'll say minus 4, is equal to 4. Okay, so now we're trying to get x by itself. So 2x, what do you have? Plus 3a minus 4a is a single a. If we move the 1 over, you're going to get 5. You're going to get 2x is equal to 5 minus a, and x is equal to 5 over 2, or 5 minus a over 2. You can leave it like that, 5 minus a over 2, okay? All right, so my final answer, even though it's infinite solutions, you write it in this form, 5 minus a over 2. The y is going to be 4a minus 1, and then z, of course, is equal to a. So typically when you get infinite solutions, you want to write it in a particular form, okay? And basically you just do an a substitution, let z equal a, and then you keep plugging back into the previous equation above it and then previous equation above that, right? Because we're in row echelon form, it's easier to substitute. All right, so let's do one more example. We talked about square and non-square systems. So here is an example of a non-square system. So you have x minus y plus 2z is equal to 5. 3x minus y minus 2z is equal to 21. Okay, so I already know that this is a non-square system because there's only 2 equations and there's 3 variables, right? So if it's a non-square system, it means you're not going to have a unique solution. So you already know that most likely you're going to have infinite solutions. Now, can you still put this in row echelon form? Absolutely, right? We want to get rid of the x right here, the 3x, right? So let's get rid of it. Let's multiply row 1 by negative 3 and add it to row 2, and let's replace that with row 2, okay? So let's do some math here. Negative 3 times x is negative 3x plus 3x is 0x. Negative 3 times negative y is positive 3y. Positive 3y minus y is 2y. Negative 3 times 2z is negative 6z. Negative 6z. Negative 6z plus negative 2z is negative 8z. And then negative 3 times 5 is negative 15. Negative 15 plus 21 will just give you 6. Okay. Okay, so you are technically in row echelon form. If you want, just to make things a little bit easier, later on we're going to go over this thing called row reduced echelon form. You could multiply row 2 by... Now, the row reduced echelon form basically has all the leading coefficients as 1s. Okay, so, just for an extra step, this is technically an REF already. But just for the sake of making things a little bit easier, I'm going to just do one last step, 1/2 times row 2. And this will now be in what is called row reduced echelon form. Okay, so remember, you can multiply any row by constant. Over here, you're going to get y minus 4z is equal to 3. Okay, so this is actually our REF. Okay, so you don't know what to do from here, right? And that's okay because you can't solve. This is a non-square system. So now we know it's going to be infinite solutions. We're going to let z, so we're going to say infinite solutions. We're going to let z equal a again. Okay, so if z is equal to a, right, you can back solve. Y minus 4a is equal to 3. Y is equal to 3 plus 4a. And then to solve for x, right, you plug everything back in. Okay, so make sure you put parentheses when you substitute a quantity. Z is equal to a, and then get x by itself. Okay, so x is equal to 5 minus 2a, add this quantity, 3 plus 4a. Combine some like terms, it looks like you're going to get 2a plus 8. Okay, so final answer, 2a plus 8 is my x value. My y value is 4a plus 3. And z, of course, we said was equal to a. Okay, so infinite solutions, because this is a non-square system, but make sure you are able to do this z equal a substitution, which really is confusing at first. But if you think about it, right, you're just doing basic substitution.